the difference between SIDS and obstacles. And this is a classic example that you find in your training classes where you have a known obstacle, certain height, certain distance from the end of the runway. Very simple calculation to give you an obstacle gradient, and then basically applying your net takeoff charts to this will give you your nice 35-foot clearance on a net path. Very simple calculation. Everyone does it during their initial and recurrent training. Now things change considerably when we get into climb gradients, basically SIDS, and most people are not familiar with the fact that there are actually two TURPS criteria presently in use today. They're called pre-change 19 and post-change 19. The change occurred about 3 years ago. The pre-change 19 is the classic SID most pilots are familiar with, where it begins at an altitude of 35 feet above the end of the departure of the runway surface, and goes out on its whatever the climb gradient is from there. Built into that classic pre-change 19 SID is a 0.8% gradient, or stated in terms of feet per nautical mile, it'd be 48 feet per nautical mile. 0.8% of roughly 6,000 feet in a mile gives you the 48 feet per nautical mile. This is a safety margin that's built in all SIDS regardless of how steep they are in the pre-change 19 criteria. So under that 0.8%, we can assume that if there are any obstacles, they're going to fall beneath this line. This is the assumed to be terrain area. We don't know that there's terrain there. It could be ATC requirements of some sort, but since we don't know, we have to assume that it's all terrain. Based upon this, then, we can create our required path, and in order to do that, we need to raise the normal path of the aircraft that starts also at 35 feet off the end of the runway to 70 feet, so that we can clear those close-in obstacles by 35 feet according to the regulation. And you'll notice that our gross path now will actually be above this net line, which is what we want it to be. Now, one of the products that are out there called UltraNav and some others utilize the net takeoff charts directly against the gross gradient requirement. And this will give you a doubling up, if you will, of that 0.8% for twin-engine aircraft, even more if you have 3 or 4 engines. And you can see that it close in, it doesn't allow for clearance of the obstacles that may be close in. So you not only have a more restrictive climb gradient requirement here, but you also don't meet the close-in requirements. Now, everything changes with post-change 19 criteria. You'll notice here that the SID actually starts at the runway surface and continues up for whatever the obstacle clearances are. And the 0.8% has now given way to a new 24% of the overall height requirements. If you're dealing with a 200-foot per nautical mile climb requirement, 24% is still 48 feet per nautical mile. However, as you get steeper gradients, let's say you go to 400 feet per nautical mile, 24% of that now is 96 feet per nautical mile. So as you can see, as contrasted to the pre-change 19 criteria, the post-change 19 criteria has a much greater safety margin built into it that steepens with the climb gradient requirement. One of the things that you will find is that you don't know by looking at the approach plates which criteria they use. There is no official mechanism for that. There is, however, a new requirement under post-change 19 that requires that close-in obstacles be identified. If you take a look at, let's say, the Aspen approach chart, you'll notice in there that there's an obstacle that's, 1,000 feet to the left of the center line, some 1,000 feet downrange, that's identified for you. If you notice this nomenclature in your approach charts down by where the climb gradient requirements are listed, that's a good indication that you're dealing with a post-change 19 departure, because you can always check with your local FAA office to determine whether or not that's correct or not. But that's probably a pretty good indication. But you notice here then that we can subtract this 24% to give us our assumed terrain area, and it allows us to get a little more weight out of a particular airport if we can do that. We also don't have to raise the aircraft actual performance to 70 feet. We can just use the normal 35 feet that coming straight out of the charts. The way we do that, by the way, just as point of information, is that we look at the first segment data for the aircraft, and we determine what horizontal distance is required to climb an additional 35 feet in first segment, and we simply subtract that from your runway length. It's usually nothing more than 100 feet or so, a couple hundred feet, and but it is a little more restrictive, so if you can use the post-change 19, then by all means do so, because you'll come out with a little heavier weight. Also notice here that your actual gross flight path may in fact go below the actual SID. This is acceptable because we're not trying to maintain the SID, because we're in a one-engine in-op situation here, and we're in an emergency procedure, and we're certainly allowed to deviate from the SID under these conditions. What we are maintaining at this point is this 35 feet clearance over with a net path over any obstacles, and we're assuming everything beneath that net path or net gradient is terrain. So we'll show it to you side by side there, and you can see the differences.